Welcome to Easy to Learn Technical Skills. Today I am going to explain about the concept of polymorphism in C++. What is polymorphism in C++? Polymorphism is a combination of the words like poly, which means that many, then morphs, which means that forms, which together we can call as many forms. So which means that a same function name with the different kinds of meaning with the different kinds of operations. So that is what we can call as many forms. The example I like to take here, the vehicle as well as men and women. If you are saying is a men, the men having different kinds of activities based on this working place, based on his family, based on his friends, we can call the different kinds of aspects in the form of men or women. Another one is called as a vehicle. So if you take the vehicle class, the vehicle can be either car or bus or two-wheeler or four-wheeler or train, whatever it is, everything will be common like vehicle. So under the same name we can have the different meanings. So this kind of concept is called as polymorphism. The polymorphism is referred here, the people, the men is behaving like with the different kinds of aspects. So we can call with the best example like a man or woman like a polymorphism. Another one is called as a car. So here the cab we can call with the different kinds of variation is there for the cab while we booking that. So simply we can book the named as car. So either it is AC or non-AC or a nano car. So many types of varieties are there, but simply we can call with the vehicle. So likewise we can have the same name with the different kinds of operation. So in types of polymorphism in C++, according to the implementation aspects, there are two kinds of polymorphism is there. One is called as compile time polymorphism, another one is called as the runtime polymorphism. Compile time polymorphism means those program coding will be checked during the compile time. We can call it as compile time polymorphism. And the next one is runtime polymorphism. During the execution of the program, the particular piece of the coding will be evaluated. So that is called as a runtime polymorphism. So in the compile time polymorphism, we can call as early binding, and the runtime polymorphism we can call as late binding. So in compile time polymorphism, the early binding is going to be happened. So which means that all the function definitions, everything will be bind together during the compile time. So if anything is happening during the compile time, it will throw the error. So there are two kinds of implementation is present in the compile time polymorphism. The first one is function overloading, second one is operator overloading. Compile time polymorphism. So the compile time polymorphism in C++, which takes place that during the compilation time, the compiler determines which function call is matched with the which definition part. So which means that based on the signature, based on the type of the function definition, based on the parameters, is based on the type of the parameters. So all the thing will be considered, and that will be bind before the program is going to be executed. That is what we can call it as this is a compile time polymorphism. There are two types of compile time polymorphism is there. The first one is function overloading, second one is operator overloading. What is called as function overloading? So one or more functions may have the same name with a different kind of parameter is called as function overloading, which enables same function name to be performed the various tasks based on the parameters provided to the user. And this is an example of function overloading. So here we are going to have the class name is called as overload, and within the curly braces we are going to mention all the definitions under the same name. So here the definitions are, here the function name is called as a print, so which is going to have the data type like void and going to have the parameter having one integer type argument is there. And here the same another function is having with a double argument. Another function is definition is having the same name but with the string argument. So this is the way we are going to have the multiple function names under the same name with the different kinds of operations. So while we are going to call this methods using the function call, this is called as a signature. So which means that the type of the argument is going to be considered as the difference. So now if it is 5, it is exactly matched with the definition part. Any one of the definition part must be matched, then only this particular function call will be executed. So here the 5 is called as the integer type. So in this definition part, any one of the function definition should be matched. So here this function definition having only one argument along with the type is integer, and here the signature is matched. So which means that this function call with even though the same function name, it will be identified by the respective definition part and this part alone to be executed. So this kind of technique is called as polymorphism. So this is called as early binding. So before going to execute this program, so this compiler identify the respective definition part based on the signature and able to bind like one binding. So while we going to bind this situation, So the compiler can able to easily going to do the process. So this concept is called as compile time polymorphism. Operator overloading in C++. The operator overloading empowers the operator have the special meaning for the specific data types. For instance, we can redefine the addition operator plus for the string class that will be considered as a concatenation, and based on the position where the plus operator will be behave like a different manner. So this concept is called as operator overloading. So here we are going to overload the functionality of the given operator. So the flexibility allows to extend the functionality of operator beyond their conventional usage. Conventional usage means addition. So here some of the operators can be overload and some of the operators can't be overload, like a dot operator, then scope resolution operator, type id, size, and these are the operators can't be overloaded. Then the operators can be overloaded like a plus, minus, division, star, modulo division, plus equal to, minus equal to, divide equal to, then boolean algebra operators, bitwise manipulation operators, memory management operators. So these are the operators can be overloaded, and the few operators can't be overloaded. This example I'm going to explain about the concept of operator overloading, and this program I'm going to have the class name is called as string concat, and the operation is going to be happen like string concatenation. And there are two constructor is there, one is default constructor and one is parameters constructor, and within the main function I'm going to create the object for the class is called as string concat. The first object is created for the object is value is called as a hello, and second object is called as str2 with the value is called as world. We are going to have the another object is called as a result, which is going to have the str1 plus str2. So this is the way we are going to overload the operator. Here the meaning of the operator is going to add two objects. So while the object will be forwarded to this operator, this operator going to takes the value of the str1 and the str2. So here the object will be received as usual with the help of the creating the new object only we are going to receive the object. So this object is going to have the one value and this str is going to another value. So this plus operator now going to do the concat operation. So this is a way the operator can be behave in different manner. So in this part it is going to have the operations of object, and this part going to have the operations of strings. So likewise the behavior of the particular object can be placed in the, based on the role of the operator, which will be placed in the position also. So this concept is called as operator overloading. So we are going to overload the existing behavior of the plus operator in different places. So this concept is called as operator overloading. The another type is called as runtime polymorphism. In runtime polymorphism, after the early binding, we are going to do this runtime polymorphism. Runtime polymorphism means called as late binding. So which can be explained in two ways. One is called as function overriding, another one is called as virtual function. Runtime polymorphism in C++. Runtime polymorphism in C++ that allows the function call resolves in during the runtime execution. So instead of the compiler time, which achieves during the function overriding and the virtual functions. This is enables the dynamic dispatch, and the another way we can call it as late binding. So which means the correct implementation chosen based on the actual type of the object. How it can be works. Use base class pointer or reference to call derived class methods, and require the virtual keyword in the base class if it is function overriding to avoid the ambiguity. So function resolution happens at the runtime used via virtual table and the virtual pointer. How the runtime polymorphism works internally? There are two things already I said. The first one is virtual table. A table can maintain all kind of objects and their respective operations. So the table of function pointer maintained per class for the virtual function. So virtual pointer is a pointer which can able to identify the respective objects. So virtual pointer in objects that points to the class virtual table. When calling the base pointer of show, for example, if the base class may have the show off method, the base class pointer, if I give the pointer access, it will access the respective function definition during the runtime execution. It will call the respective implementation. The runtime polymorphism achieved through the help of two ways. One is function overriding, another one is called as a virtual function. Function overriding occurs when a derived class provides new implementation of a function that already defined in the base class. So which means that one or more derived classes or the parent class may have the same function name is called as function overriding. So during the compilation time, there is no error will be shown because all the thing will be present within the block of code. So there is no error will be shown. but during the runtime the compiler will get confused that which function call we need to be call actually. So this is called as function overriding. Function name must be same. Key characteristics of the function overriding: function name must be identical in both base classes and the derived class. Function signature also must be same. For example, parameter order is same, parameter type is same, then return type also same in the derived class function as well as the parent class function. The base class function must be marked as virtual to enable the runtime polymorphism. The function resolution happened during the runtime dynamic dispatch using this base class pointers reference. In this example, I am going to explain the concept of function overriding without using the virtual function. So here I am going to have the parent class name is called as polygon, and here the derived class name is called as rectangle, and here the derived class name is called as triangle. Suppose if I am going to have the three classes having the same function name is called as, the same signature is called as data type function name parenthesis, and here also data type function name parenthesis, and here also data type function name parenthesis, everything is same. But during the compilation time there is no error will be shown because all the syntax everything is same. So this will be present during this within this block of code, and this is present within this block of code. So compiler thinks that everything is same and same function name is there, function call also there, so compiler can able to bind perfectly. But the compiler will get confused that which function call we need to call during this function call, because all the function calls are same, all the definitions are same in the derived classes as well as the parent class. Now we have the object creation for the respective classes. The first one is called as a rectangle, we have the triangle. So we are going to create the object for the given classes. The first one is called as a rectangle class object, second triangle class object, third one polygon object. And here we have to create the object for the parent class using pointer. So here the polygon, in the polygon we are going to create the object for the pointer object for the given class, and the input is ampersand rectangle. Then polygon object we are going to create another object using the pointer, and the input is called as triangle. Then polygon, another one is called as a poly3 pointer poly3, and the reference we are going to give the object of the base class. And now here we are going to set the value like a first function call. So the set value method will be called here. Here we have to set the value of the x and y, and likewise we are going to three function calls, three times the value will be set for the different function calls. And here we are going to call the respective function call using this area of method. So in this area of method we'll get call this using this value like a 1020. In this part it is going to get the area value. So here the area value is called as 0 because it is going to call the poly1. So what is called as poly1? In the rectangle class it is going to call the poly1. So now I am going to create the object for the parent class. So through the parent class I am going to create the object pointer object, and through this pointer object we are going to give the reference of the rectangle class, triangle class, and poly class. So while we calling this method using this parent class object only, that is what it is always going to call the parent class. So here the parent class we have the return value is called as 0. So if I have this area of method is going to have the 0, that will be printed here as the rectangle value is called as 0. And here the next function call is area, but still it is going to refer the parent class pointer only. So if it is a parent class object, always it is going to call the parents class definition. In this parent class definition we have the return value is called as a 0. That is what this area is going to get the value like a 0. So it is always going to call the parent class only. So this is a drawback of without virtual function if you are going to use the function definition as same. So the function overriding is override the existing characteristics, so we can't able to get the actual output for each and every definitions. So this is always going to point to the same function definition alone. So this is what we are going to get the answer as 0 in everywhere. If you want to overcome this situation, you just go with the concept of virtual function. So in virtual function also we are going to take the same example but with the help of the virtual keyword. So what is called as virtual function? Virtual function in C++. Virtual function in C++ is a function, the base class declared using the virtual keyword. It must be overridden in the derived classes. So which means that one or more derived classes and the base classes may have the same function name, but the base class function name you have to give the keyword is called as virtual data type function name. It is meant to overridden in derived classes to achieve runtime polymorphism, which is called as a dynamic binding. When a base class pointer or a reference call in a virtual function, the virtual function of the derived class is executed if it is overridden. So which means that the parent class may have the virtual function, the function definition is overridden, which means that the derived classes also may have the same function name, which is called as overridden. If the thing is present in the position of virtual function along with the subclasses without a virtual function, the compiler will directly forward it to the instruction to the derived class function definition. So this concept is called as virtual function in C++. Key features of a virtual function: declared using the virtual keyword in the base class, supports runtime polymorphism, that is called as a dynamic dispatch. The overriding function is derived class must have the same signature, the base class function whatever it has, except the virtual keyword. Base class pointer or reference called the most derived version of the function helps in achieving dynamic behavior of the object-oriented programming. So these are the features of virtual functions in C++. Same program along with the virtual keyword. So see here, the class name is called as polygon, and here we have the two variables we declared in the protected because we are going to use the inherited concepts, and here the function name is called as virtual int area, which means that this is called as a base class signature, base class function definition signature along with the virtual keyword, but this is the common type we are going to use in the derived classes, int area of and the open and close curly braces. See here, in the derived class name is called as rectangle. In this derived class we are going to use the same function name with the same type of argument. The signature everything is same, so here also the signature everything is same, but the base class we are going to use the virtual keyword. Now the compiler can able to identify the definition is virtual, immediately it will forward it to the respective function definition in the derived classes. And here also we have the same type of object creation whichever we see in the previous program. So here the rectangle class is there, the object is created. Triangle class, object is created. Polygon, object is created. Through this parent class only we are going to give the reference of the each and every subclasses objects. See here, the polygon is the parent class object, parent class name. Through this parent class we are going to forward the ampersand rect, which means the derived class object. So this object is going to refer the parent class. Through the parent class only we are going to access everything. So here polygon pointer is a variable, can able to access the address of this rectangle value, and here triangle also going to access the polygon, and which is going to be p poly 2, and this ampersand poly which is going to access p poly 3. Now we are going to have the set values method. So this p poly 1 we are going to set the value of the parent class function name is called as set value. The value is called as 10, 20 will be set here initially. X and y can carry the value like 10 and 20. Second time 10, 20 will be forwarded. Third time 20, 20 will be forwarded. Now we have the function call p poly 1 area of. So while we calling this function call, so this function call will be called in the respective definition part. So which is called as a virtual, which is present in the parent class property. So now the parent class property says that this function is not a original one, this is a virtual one. So immediately the control transfer to this part. So here it is going to refer the ampersand rectangle. What is ampersand rectangle? Which is called as a rectangle class. So immediately it will forward it to the rectangle class, and this rectangle class we have the function is called as int area. So we are going to do the calculation of 10 into 20. So while we executing this program, you may get the answer as called as 200 here. Why? Because the respective function call will be called in the parent class, but the parent class says that that is a virtual, not a original. So now the virtual function able to transfer his job to the derived class method. So in this derived class we have the method is called as int area. So this function definition can be worked for this function call. That is what we got the answer as called as 200. Initially without function virtual function we got the answer as 0, but now we got the exact answer in the derived classes. And the next one is called as area of, and in this area of is present with the parent class property only. So it is immediately forwarded to the virtual function. So the virtual function, whenever we are seeing this is a virtual, immediately the control transfer to the respective function object creation. Say here it is referred to the respective object is called as ampersand trgl. So immediately the control transfer to the triangle class, and this triangle class we have the function is called as area of. In this area we are going to do the operation 10 into 20, so that is called as a 200 divided by 2. The answer is called as 100. That is what we are going to get the answer is called as a triangle. And third time if you are going to call this area method, so in this area method we are going to call the same virtual function. So here the virtual function is called, but this function says that this is virtual, not a original one. So immediately it control transfer to the poly. So in this line we are going to refer the same polygon. So again it will call the same method. So that is what we are going to get. The final answer is called as a 0. So the polygon class we are going to have the value like a 0. So the virtual function is a function is going to tells which function, which definition part can be worked in the correct way during the runtime execution. Function overriding and function overloading. When function overriding, the definition it will be redefined within the derived classes. Function overloading, everything will be present within the class with the different kinds of arguments with the same name of the function. Parameters, most of the same as the base class function. So here it must be defined with the different types of arguments, or else it will throw the error. Virtual keyword, yes, recommended in the function overriding to exactly point into the respective function definition, even though the function name is same. Here the function overloading, there is no virtual keyword. Binding, this is a runtime polymorphism, so this is a late binding, and the name is called as a dynamic dispatch. And the function overloading, that is compile time polymorphism, so static binding or early binding. Pure virtual function in C++. C++ pure virtual function has no implementation in base class and must be overridden in the derived class. So declaring a function as a pure virtual makes that class is an abstract class, meaning it cannot be instantiated. Virtual return type function name parenthesis is equal to 0 semicolon. So this line must be present in the parent class. So based on the function name we are going to use in the derived classes, we can redefine once again with the help of this same function name, same type of function name. The equal to 0 is the end of the function declaration, indicates that the function is pure virtual function. Key pointers of the pure virtual function is a class containing at least one pure virtual function is called as abstract class. So while we defining the abstract class in C++, so we are going to have the virtual keyword along with the function name. The function name should not be expanded, and the after parenthesis is mentioned as equal to 0. The abstract class cannot be instantiated directly. Instead of that, we are going to create the derived classes. So the derived class we are going to expand the function definition. For this derived classes only, we are going to expand the function definition, and we can able to create the instance of the derived classes. Derived classes must be override all pure virtual function, otherwise they also become abstract classes. Base class pointer or reference can be used to call the function overridden function dynamically. Pure virtual function force derived classes to provide the specific functionality. So the base classes cannot be defined, only the derived classes alone going to be defined the function definition if it is a pure virtual function. So the pure virtual function is implemented in C++, which helps to implement in the abstract classes in C++. So this is called as a pure virtual function. In this pure virtual function, as I said, the virtual keyword we have to use along with the data type, function name, and is equal to 0, which is called as a pure virtual function declaration. And this function void welcome of, this is a function definition will be present in the derived classes. See here the college class college, and this is a Sintel department in the which is present in the college. So class Sintel, it is derived from the college. So here we are going to expand the definition part in the Sintel and class, and here the CTEC is another class which is derived from the college, and here also we have the void welcome of. So this void welcome of will be present or expanded in the derived classes, but in the base class it should not be expanded, which is mentioned with equal to 0. Then while we creating the object for the given class itself, the respective constructor part will be executed. And while we creating the object in the main function, see here college star s1 is equal to new scintilla, which means that s1 is the object which is going to create through the help of the parent class. So the parent class we created the object for the Sintel as well as the CTEC. So there are two objects we created, s1 and s2. Those objects will be called, and here s1 will be called the respective definition part through the help of the virtual table. See here the welcome of this function will be able to call the respective definition part, and this is the first one we will get the answer, and second, and this welcome of will be returned the second derived class which is called as ctech. And while we executing this one, we may get the different answer. So the answer is welcome to Sintel department, welcome to ctech department. And finally you have to delete all the respective objects whatever we created through the help of the new keyword. So this is a way the pure virtual function will be work. So we cannot be touch this one to during the execution time, and we cannot able to access this one because this is abstract class. So what is called as abstraction? Abstraction means hiding the implementation detail, and you can able to access only the respective details whatever it can be provided to the developer. So here this part will be purely abstracted, so we can't able to touch during this execution part, but we can able to expand it through the help of their derived classes. So this void welcome is a method can be derived from the base class properties called as virtual void welcome is equal to 0. So this concept is called as pure virtual function. Thank you for watching my channel. Thank you.